Namaste friends, I hope you are following the physics video lectures. Today our goal is to learn about what is the time taken when a body is sliding from an inclined plane. That is our goal. So the time taken in sliding a particle down. You already know what does that mean by inclined plane. So let me take, this is the inclined plane. The height of the inclined plane is h. The distance of the inclined plane is s. The inclination angle is theta. This is the horizontal plane, it is the inclined plane. The length of these length or distance of the inclined plane is s. So from this diagram we can easily say that the sin theta is equal to opposite side h divided by hypotenuse s. Let me take this diagram p, q and r. Now our goal is to find out what is the time taken to travel this body. Here is the body is there. Now let me take one small toy car is there. The toy car is sliding down like this. Now how much time taken to reach the toy car from R to P? That is our goal. So we already discussed what is the acceleration will act towards this direction. That value is equal to g sin theta. If you have any doubts means please go through the last video how we resolved this one, g sin theta value. So because of g will act downward direction, if it is the theta means then g sin theta will come along this direction. As this motion we are taking is the positive direction, here we are taking the coordinate system. We assume that here is the coordinate system, along this direction coordinate system all are we are taking the positive. Now what is the time taken to reach this body means we are applying the formula s is equal to ut plus half a t square. This formula we are applying. So to apply this one, how much distance the body is traveled, that value we already known, that value is equal to s. This value is known. What is the initial velocity of the body? The particle is started from here itself, that means the initial velocity is 0. So s is equal to s, the initial velocity is equal to 0 because of it is started from r only. That initial velocity is 0. What is the acceleration along this direction? That acceleration is equal to g sin theta. The time taken is equal to t. We need to find out that one. Substitute these values in the above equation, that is equal to s is equal to 0 into t plus half g sin theta into t square. This is the formula we got. Our goal is to find out the t square value, then t square is equal to, send this to this side, that is equal to 2s divided by g sin theta. This is the formula we are getting. Now come to this one, that is equal to, now from this diagram sin theta is equal to h by s. Here is the sin theta is there, so I am substituting, now I am rewriting this one. After this I am writing here, then t square is equal to, let me take black pen. So t square is equal to 2s divided by g into, I am writing here, I written one more sin theta, here also I written one more sin theta, then this sin theta will cancel. So then 2s divided by g into sin theta is equal to sin square theta, then sin theta value is equal to h by s is there, that value I am substituting, h by s, s both are cancelled. Then that is equal to 2h g sin square theta, but 1 by sin square theta can be called it as a cosec square theta, that is equal to cosec square theta, because of what is the formula? Cosecant theta is equal to 1 by sin theta, because of 1 by cosec theta is equal to sin theta, or 1 by sin theta is equal to, here is the 1 by sin square theta is there, that's why cosec square theta we got. Then t square is equal to, from this equation t square is equal to root of this entire this equation, otherwise I will write here. Then next step I written, so the t square is equal to root of 2h by g into cosec square theta, also root over root will come, that root and square will both will cancel, that cosec theta. This is the very important formula. Then, sorry, t square, not t only. What does that mean? From this equation we say that the t value, the time taken body to reach the ground is directly proportional to its cosec angle. So it is directly proportional to its cosecant angle of the inclination. That is the very important one. So the time taken varies directly proportional to the cosecant of the angle of inclination. From this one we are getting, so if the cosecant, the angle is varying, that the time will also vary according to the cosecant angle of the inclination. That means we are taking the two inclination values. Here is the one inclination, another one is the bigger one is there. This angle is the theta 1, this angle is the theta 2. The sides are both are same. Let me take both sides are same. So I drawn here somewhat different different length of this hypotenuse value, but you feel that these sides are equal. Then the time period will equal to t1 divided by t2 is equal to what we will get, cosecant theta 1 divided by cosecant of theta 2. This is the very important one. Now if the angle is same but the distances are, the heights are different, angle is same and heights are, so then what we will get, angle is same, height will different will come? No, it won't come, because of this h is the depending parameter on height. That's why we cannot justify this one. So then the conclusion here is that t1 by t2 is equal to cosecant theta 1 divided by theta 2. This is the very important formula, otherwise they will provide this formula we need to use to solve the problem. So let me stop here. I hope you understand what is the time taken to reach the body to slide from top to bottom of the inclined plane. That value is equal to t is equal to square root of 2h by g into cosec theta. That is the very important, and conclusion is t1 by t2 is equal to cosecant theta 1 divided by cosecant theta 2. That is the very important one. Thank you for listening. Thank you.